Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, from today onwards, we are going to start General Science Chemistry, useful for all your competitive examinations like RRB JE, ALP, NTPC, Group D, SSC, CGL, CHSL, JE, MTS. Okay, so let us start the session, guys. I am starting with the very important topic in chemistry, that is acids, bases and salts. Okay, acids, bases and salts is a very important topic. Coming to the first one, acids. Coming to the first one, acids. These acids are sour in taste. Acids are sour in taste. Whenever we have the word acid, we have to get in our mind citric acid. Citric acid is present in citrus fruits like lemon, oranges, like that. Okay, so those are, for example, let us take a small amount of lemon juice that is very sour in taste. Correct. So we can get the idea acids are sour in taste. Very, very important topic. Note down. Acids are sour in taste. Very important point. Okay, and these acids are convert blue litmus to red litmus. Acids converts blue litmus into red litmus. Okay, so note on that important point. Acids change the color of blue litmus to red litmus. Okay, we have so much of confusion on this point. That is, acids converts blue to red or bases converts blue to red, like that. Here I want to give a small trick to remember. Small trick to remember. That is, here blue litmus to red litmus. Which is converting blue litmus to red litmus? That is acid, na? So make that A here. So the simple trick is nothing but bar. Bar and restaurant. Okay, so here bar, see, convert blue litmus to red litmus. In simple way we can remember. So if you remember, for acid, acid convert blue to red. For base, reverse, red to blue. For base, it is reverse, red to blue. So like that we can simply remember and we can avoid the confusion. Okay. So the very important point in the acid, acids are sour in taste. So how to remember that one? So for example, citric acid that is present in lemon or oranges, that is the taste is sour. Okay, so we can simply remember acids are sour in taste, and acid change the color of blue litmus to red litmus, that is B to R. Okay. In the same way, let us take a base. Let us take base. Bases are bitter in taste. Bases are bitter in taste. Okay, so you can simply remember B for B. Okay, so all the metals are bases. Okay, generally you have to remember a very important point. Metals are basic in nature. Okay, like sodium, potassium, calcium, okay, copper, aluminum, all the metals are basic in nature. In the same way here, non-metals, non-metals are acidic nature, acidic nature. Okay, for example, hydrogen, chlorine, sulfur. So all those are non-metals, those are acidic nature. So bases are bitter in taste, acids are sour in taste. Here the second point. Acid change the color of blue litmus to red litmus, na base is reverse. So note down the point. Base change the color of red litmus to blue litmus. Blue litmus. Okay, we know the litmus paper. Okay, so here we have one more important question. That is, the litmus paper is made with dash. Litmus paper is nothing but it is one of the indicator. One of the indicator. That means it gives the idea the solution is acid or base. Okay, these litmus papers are generally made with from a tree that is called lichen. That is called lichen. That is a very important bit. Okay, note down that important bit also. Here bases change the color of red litmus to blue litmus, which is converting base. Okay, so you can remember RBB. Here litmus is indicator. Have so many indicators. Okay, and made from tree called lichen. Very important question. Note down this point. Okay, here in this series we are going to discuss each and every important point which may comes in the examination. Okay, so we don't discuss any unnecessary data. So all the points are very important. Okay, so here the series are mainly exam oriented. Okay, and you can cover a lot of syllabus within less time. And coming to the next point, and also we will discuss about the indicators in later sessions in detail. Don't worry about that. Coming to some important properties. Some important properties of acids. Okay, coming to some examples of acids. Examples of acids. We have so many examples of acids. For example, industrial acids like H2SO4, HCl, HNO3. Okay, some weak acids like acetic acid, CH3COOH. Okay, so these are the examples of acids. So what I said the point, non-metals are acidic nature. Okay, so here in the acids we have non-metals like hydrogen, sulfur, oxygen, hydrogen, chlorine, hydrogen, nitrogen, oxygen. Okay, carbon. So all these are made with non-metals. So that is the simple idea to get here. Okay, so sorry, remember that important point here. Okay, so non-metals are acidic in nature. So properties of acid. First important property, reaction with the metals. Very important point, reaction with the metals. Okay, so generally these acids react with the metal and it will give which gas? That is the important question here. In the examination we will get a question, acid react with the metal will give dash gas. Okay, whenever acid react with the metal it will give salt plus hydrogen gas. That is the important point here. Hydrogen gas is released. Let us take any one acid in this. Let us take any one acid in this. For example, I am taking HCl. HCl. One metal. I am going to take sodium is a metal. So then sodium plus HCl. Here NaCl plus hydrogen is the gas H2. So to get the two hydrogens, we have to take here 2. Then 2 chlorines are there, so we have to take 2 here. Then 2 sodiums means we have to take 2 here. So whenever the acid react with metal, it will give one salt and hydrogen gas. This is the important point. Hydrogen gas is released. Okay, this is a chance to come in the examination. Okay, coming to the second point. Whenever acid react with metal carbonate, metal carbonate, or metal hydrogen carbonate, hydrogen carbonate. It will give carbon dioxide, CO2 gas. That is the very important. It will give salt plus water plus carbon dioxide as the gas. So it is the very important for exams. Okay, let us take any one acid, HCl, metal carbonate, sodium carbonate, Na2CO3. I am taking the example. Then you will get a salt, NaCl plus water plus CO2. Now I am going to balance the equation. Two sodiums are there, we have to take 2 here, 2 NaCl. And 2 chlorines are there, means here we have to take 2 here, then 2 chlorines are balanced. Okay, CO2, okay, one oxygen is there, and 2 hydrogens are there, so H2O, it is also balanced, so CO2 gas is released. This is the important point. They will give the question like that. Whenever HCl is reacted with the sodium carbonate, which gas is released? Carbon dioxide. Or they will give like question, acid react with the metal carbonate or acid react with the metal hydrogen carbonate, which gas is released? That is CO2. Okay, those 2 points are very important, guys. And third point, very important. Whenever acid react with the base or base react with acid, then what will happen? Whenever acid react with base or base react with acid, what will happen? Then what will happen? Those effects will be neutralized. Acid effect is neutralized by base. Base effect is neutralized by acid. So we are getting the neutrals. Okay, we are getting the neutrals. Salt plus water. Okay, salt plus water. So here, let us take any one acid, HCl, one base, NaOH. Now, HCl will become H plus Cl minus. NaOH becomes Na plus OH minus. So Na plus Cl minus NaCl, H plus OH minus H2. So that means it is the salt, it is the water. So whenever the acid react with the base, we will get salt and water. That means the effects are neutralized. So this process is called as neutralization. This process is called as neutralization. That is a very important point. Okay, so note down here. Very important point. When acid and base react each other, then salt plus water is formed. That means neutrals are released. That is acid and base effects neutralized. So this process is called as neutralization. Very important for exam. Neutralization. Okay. Process is called as neutralization. All of you got it? And the next important property, acid gives hydronium ions. hydronium ions. Generally, we denote it as H3O plus. Use hydronium ions where? In case of water. In case of water. Okay, this is also very, very important. That is, for example, acid. If you add with the water, then you will get H3O plus and Cl minus. This is the hydronium ions. Okay, hydronium ions. And another important point, like some acids like H2SO4, HNO3, okay, H2SO4, HNO3, HCl, sorry, HCl are good conductor of electricity. Good conductors of electricity. That means they allows the electricity through them. That is also very important. Okay. So they will give the question like in the following, which is not correct. They will give the question. They will give one option. Acids like acids are not a good conductor of electricity. That is the wrong one. So those are good conductors of electricity. Okay. All of you getting? Here some important points I want to give about H2SO, sulfuric acid. Sulfuric acid. Okay. So I will give the idea about which is a strong acid, strong base, weak acid, weak base later while discussing about the pH scale. Up to now, you have to remember this one important point. Sulfuric acid is the strongest acid. Very, very strong. Strongest acid. So that's why it is called as king of all acids. Very important point. King of all acids. King of all acids. They will give the question like with the following, which is the king of all acids, that is H2SO4. And it is used in batteries as electrolyte. Used in batteries as electrolyte. So that's why it is called as battery acid. In the following, which is the battery acid, that is H2SO4. Very important question. This one also. All these are previous questions, guys. So you have to note down each and every point. It is also called as most fundamental industrial acid. Most fundamental industrial acid. So it is also one of the previous question. Following, which is the most fundamental industrial acid, that is H2SO4. Okay, and its pH. Why you can say it is a strong acid? Its pH is very near to 0. Very near to 0. That means you can say its pH is 0 to in between 0 to 1. Okay, 0 to 1. Note down all these points. H2SO4 is the strongest acid. It is also called as king of all acids, and it is used in batteries. So you can say it is the battery acid, the most fundamental industrial acid, and its pH is very near to 0. 0 to. Okay. And mixture of HCl plus HNO3 is called as aqua resia. Aqua resia, used in dissolution of gold. This is also very important. Okay, so that means these strong acids, these acids like H2SO4, HCl, HNO3, so mostly used in all the industrials. Okay, so these are the industrial acids. Industrial acids. Now coming to some natural occurring acids, some natural acids that is generally present in food. Okay, so for example, let us take lactic acid. Let us take lactic acid. Lactic acid is present in lactic acid. So this is present in sour milk. Okay, sour milk. L is the L is domination. Okay, so sometimes they will ask about formula also. They will ask about formula also. So what is the formula of lactic acid? C3H6O3. Or sometimes they will ask the question like, in lactic acid, how many carbon atoms? One of the previous question. How many carbon atoms? How many here? 3. So like that, we have to give the answer. Okay. Now coming to the next one. The acid present in ant sting or any nettle sting. So what is the acid present in ant sting or nettle sting? That is formic acid. Formic acid. Let us take in the reverse. Formic acid and sting or nettle sting. All these are previous questions and very important. And coming to this formic acid, chemical formula HCOOH. So here how many carbon atoms? One carbon atom. If one carbon atom, then what is the first name of hydrocarbon? If one carbon atom is first name is meth, na? If two carbon atoms, eth, meth, eth, prop, but, pent. We will discuss in the carbon and its compounds. Don't worry. So up to now, if it is a one carbon atom, meth, two carbon atoms, eth, prop, but, pent, like that. So one carbon atom means first one meth. Okay, and it is COOH means oic acid. COOH means oic acid. So it is also called as methanoic acid. Methanoic acid. Okay. So another name of formic acid is methanoic acid. Okay. Is another name or chemical name of formic acid. Very important question. The following, which is another name of formic acid, that is methanoic acid, or chemical name of formic acid, that is methanoic acid. Okay. Now coming to the next one, acetic acid. Acetic acid. Generally, these natural acids are weak acids guys. Generally, natural acids weaker than industrial acids. Industrial acids like H2SO4, HCl, HNO3 like. Okay, acetic acid. What is the formula of acetic acid? CH3COOH. Okay, so how many carbon atoms are here? Two carbon atoms. Two carbon atoms means eth, na? First name of hydrocarbon is eth, and COOH means oic acid. So we can call this one as ethanoic acid. Very, very important question. The following, which is also called as ethanoic acid, that is acetic acid. Okay, so this is present in generally vinegar. Present in vinegar. Okay, very important question. So generally 4 to 5% of acetic acid is present in vinegar. 4 to 5% of acetic acid is present in vinegar. Now coming to the next one, tomatoes. That is oxalic acid. Oxalic acid. So formula HOOCCOOH. Okay, present in tomatoes and also spinach. Okay, so in the spinach and tomatoes, oxalic is present. So that is some old people say that don't mix tomatoes with the spinach. Why they are suggesting like that means whenever we eat so much of tomatoes and spinach together, then oxalic acid content will be more. So that may be chance for that may be cause for forming of small stones in the kidneys. Okay, so that's why they are saying like that. But in small quantity, there is no problem. So the main reason behind that is in the tomatoes and also spinach, oxalic acid is present. The content is more. Okay, and this acid is generally used to clean the ink spots on the cloths. Okay, so to remove, that is also very important previous question, is used to remove stains, generally ink spots from cloths. Okay, that means don't use tomatoes for cleaning the cloths. Okay, so generally a small amount of oxalic acid is present in the tomato, so don't use the tomatoes to clean the cloths. Okay, coming to the next one, the formulas are very important. Okay, and don't worry, at the end of this session I will give some tricks to remember also. Okay, and coming to the next one, citric acid. You know very well about this citric acid, present in citrus fruits like lemon, oranges. So these are the taste of this lemon and oranges, sour in taste. So that means you can say acids are sour in taste. And the formula of this citric acid, C6H8O7, C6H8O7. And the coming to the next one, tartaric acid. Tartaric acid. Okay, so tartaric acid is present in tamarind and also grapes The tartaric acid is present. Okay, the formula C4H6O6, C4H6O6. And now coming to the glumatic acid. Glumatic present in wheat. Glumatic acid present in wheat. Coming to the formula C5,9NO4. Now coming to malic acid. Malic acid. This is present in apples. Very important. Malic acid is present in apples. C4H6O5. Okay. And coming to tannic acid. Tannic acid. That is present in tea. Okay. So benzoic acid. Benzoic acid. That is present in cranberries, plums, prunes. Okay. Prunes. So now coming to again this one, some natural occurring acids. Those are generally uh, weaker than the industrial acids. Here lactic acids present in sour milk, formic acid. Formic acid present in ant sting or nettle sting. So let us take a small trick to remember. Ants generally forms line, correct? They are always following line or they are forming groups. That means their nature is they forms lines or groups. So form for formic acid. So remember like that. Form for formic acid. Remember like that. Okay. So now coming to oxalic acid. Oxalic that is present in tomatoes. So let us take in the tomato. Tomato. So which is the domination here? O is the domination. Na? So O for oxalic acid. So like that remember. O for oxalic acid. That is so in that way you can remember. In the formula, let us take in the formula also O's are domination. H O O C C O O H. That means H O O C twice or C O O H twice. Okay, so you can also make this one as COOH twice. So here which is the domination? Here also O is the domination. O is the domination. Okay, so you can remember like that. And how to remember spinach? If you add tomato with spinach, that is harmful for our kidneys. So may stones form because of higher oxalic acid. So that means you can remember both together, tomato and spinach. Citric acid, you can easily remember citrus fruits. Tartaric acid, ta. Here in the first two letters and again two letters, ta. Ta is domination, tamarind. Ta for tamarind and grapes. Okay, glutamic acid, GLU. Glutamic acid, wheat. Malic acid, apples. Tannic acid, tea. So these are some very important examples. Okay, important points for examination. Okay, have you got it? And while discussing important MCQs, I will give in detail about so many questions. Okay, if any point is not covered in the theory session, no need of worry, that will be covered in the MCQ session. Okay, guys. And in the next session, we will discuss some important points belongs to bases and salts. After that, we will enter into the pH scale. In that, we will discuss about strong acids, strong base, weak bases, and all those. Okay, and students, I'm requesting you, please follow at least 2 to 3 sessions, then only you will get the idea about the classes. Okay, and you can get the all the theory part and you can get the knowledge of this chemistry. Okay, just watching one session or 10 minutes, 15 minutes, you may not get anything. Okay, so you have to match the frequency of any educator, then only you will get the maximum knowledge. Okay, and students, if you want to download the PDF of this theoretical notes or MCQs, okay, so you can visit sunilengineeringacademy.com. Okay, so in that you will get the theory part and also MCQs. Okay, you can download very nominal price. Okay, and students, I request you, please share these videos to all your friends. Okay, thank you so much, guys.